So we will continue with the derivation for TE waves. We know the condition for TE mode is E SZ is equal to 0. Now I am going to substitute this condition in my equation 1, 2, 3 and 4, that is this one. 1, 2, 3 and 4 I will substitute E SZ is equal to 0. So finally the components will look like this. Esx is equal to this one minus j omega mu x square dou hsz by dou Ey, then Essy, Hsxy and Hssy. Okay, that is equation 18, 19, 20, 21. I am simply substituting E is equal to 0 in 1, 2, 3 and 4. Next we have to find Hsz using boundary condition. So as explained earlier, boundary condition is Esy is equal to 0 at x is equal to 0 and x equal to a. Okay, so I will substitute in equation 19. So what happens? Again write dou hz by dou x is equal to 0. This term will become equal to 0 when x is equal to 0 and x equal to a, right? Similarly, you know Esx is equal to 0 for y equal to 0 and y equal to b. So when I substitute this condition in equation 18, what happens when Esx is equal to 0? What happens to equation 18? Equation 18, it becomes, this term becomes equal to 0. So I can write dou hz by dou y is equal to 0, right? That is written here. So what I have done is, I have used the boundary condition which I defined earlier, that is Esy is equal to 0 when x equal to 0 and x equal to y in equation 19, and Esx is equal to 0 for y equal to 0 and y equal to b in equation 18. So we have the two conditions, equation 22 and equation 23. Now apply 22 and 23 to solve for wave equation of Hsz. Now using this 22 and 23 we can solve for Hsz, and finally we will get Hsz as equation 24, which is same as that of Esz, that is this one. This is equation 1 and this one equation 24, both are the same, and this is also known as the waveguide equation whose solution gives the wave equation. Okay, so Hsz is a1 cos kxx plus a2 sin kxx into a3 cos kyy plus a4 sin kyy exponential minus gamma z. So what I have done is, I have applied 22 and 23 to solve for wave equation of Hsz, which is same as Es0. Okay. So that is my equation 25. Sorry, equation 24. Next, what I have done is, I have differentiated this with respect to x, and that is my equation 25. Now what I have done is, I applied 22 in 25. What is 22? 22 is dou hz by dou x is equal to 0. So that is, this term is equal to 0 for which condition? For x equal to 0. So I have substituted 0 is equal to, then x term is also substituted as 0. So what happens is, wherever there is sin x, that terms, the entire term becomes 0, and only the cos term will be, where the cos term has x components will be remaining, because you know cos of 0 is 1. So when you substitute, apply 22 in 25 and x equal to 0, both, when you apply both these conditions, finally you will get 0 is equal to kx a2 a3 cos kyy plus kx a2 a4 sin kyy exponential minus gamma z. Rest of the term will be equal to 0. So from that I am taking a2 outside because it's common, a2 into this term, which implies a2 is equal to 0. So now I got the value of a2 as 0. Next, what I am going to do, I am trying to differentiate this with respect to y. So I have differentiated it, and that is equation 26. And now I am applying the condition 23 in 26 and y equal to 0. Both these conditions, that is dou hz by dou y is equal to 0. For y equal to 0, that condition is applied in equation 26. So that I will get finally x sz as a1 a3 cos kx x cos ky y exponential minus gamma z, and which is my expression for the magnetic component along the z axis, and where a1 a3 is my constant, can be represented as another constant h naught, and that is my expression for h s z. Now what I can do is, I can substitute this 5 in 18, 19, 20 and 21, which is my 18, 19, 20, this one, okay. 18, 19, 20, 21. Now I got the expression for h z, right? So you simply substitute here, differentiate it with respect to y in equation 18, here with respect to a, here with respect to x, and here with respect to y. And finally, I will get these four terms. Esx, Esy, Hsx, Hsy, that is marked as GHIJ, which are the components of my, what here you can see, T, E, B. Okay, so now where Kx is equal to n pi by b and Ky is equal to m pi by a, which, so you can substitute Kx as n pi by b and Ky as m pi by a to write down the final expression. And for getting the value of Kx and Ky, you can follow the same derivation which we used to derive Esz, that is this one. This one, this and this one, okay, the same derivation you can follow. And so finally I can say f, g, h, I, j are the components of T, E, mu. And that's all. I hope you could follow this derivation. Please write down and study, okay, because all these derivation, that is that of T mod, Tm mod, has been repeatedly asked for your question, for your university exam. So that's all. Thank you.